last time we looked at how to find arc lengths, right? So just to remind you what that question looked like is you'd have a circle. Its radius was r. The angle subtended in the center, that's just the phrase that they use, is theta, and the arc length going from here to here is s. And the formula for it was actually a very simple formula. It's just the radius times theta. Isn't the only thing you have to be careful here is that theta is in radians. So be careful, the units, be careful, that you make sure that the angle is in radians before you use it. Because sometimes they make it 40 degrees just to catch it. And we call that arc length. So what we're looking at today is area of the sector. So if I draw another circle, and this is r, the radius is r, and the angle subtended is there, what we're going to be looking at this time is the area of that, I don't know what you'd call it. Do you know those little pieces of triangular cheeses that you get covered in silver paper, one of those, or a wedge of cake, that kind of thing, right? We call that a sector. And the area of a sector is 1/2. Can anybody remember the rest of the formula before I write it down? 1/2 something.
I think we went over area of sector. My mind's going.
Okay, I may have forgotten to write it down. There we go. It's 1/2 r squared theta, right? So that is going to be the go-to formula for the next few questions. So you can imagine what you're going to be asked to do. You're going to be asked to find the area of a sector when you know the radius and the angle theta. Aren't they probably going to give you some questions where theta is 40 degrees just to try and catch out? And then after that, we're going to do, oh, I'll tell you the area and I'll tell you theta. Can you tell me what the radius is, right? One of those kind of questions. And then I'll give you a question where I'll tell you the area and I'll tell you theta. I think I've said that one, the radius, and you're going to tell me what theta is. So that's basically every combination that makes sense. So I'll just make up my own questions. And so suppose we have a circle of radius 10 meters, so it's a big circle. And this angle in here is pi upon 3. And we want to find the area of the sector. So it is 1/2 radius squared theta. In this case, 1/2 times 10 squared times pi over 3. That's 100. 1/2 100 is 50. So the answer as an exact value would be that. And so if they don't ask to 3 decimal places, that's the answer you'll type in into WebAssign. Have you done enough WebAssign to know where pi is? Have you found the pi button? Because you need it. Do you know when you click on that box, there's a little math thing that appears on the side? Right, let me show you that, because I don't know, not everyone is that familiar yet with WebAssign. So let me show you what that would look like in mine. Right, so here is, actually, maybe I'll do this question next, but here is the question. If you click on that guy, you can then type in anything you want, but if you want a fraction, for instance, you have to type that guy, and then you'd say 50. And if you go over here, you hit Greek letters, and then you get pi, which should be around here somewhere. Why can't I find it? There we are. And then under the answer, that would be 3. So if that was my question, right? If that was the question I've just done, can you see that that's how you would use, that's how you would do it in WebAssign, and you would use that little guy over here to get all the stuff done. On the other hand, won't you get questions where you need to do the answer to 2 decimal places, something like that? If that was, this question was, give me the area of the sector correct to 2 decimal places, what I would do instead is I would simply just go 50 pi divided by 3. And
I don't think you're showing your paper. I don't see it.
Oh, let me try that again. Thanks for telling me that. Yeah, we're doing it now? Yeah. So you basically, can't you just type it in the way you see it virtually? And if I wanted the answer to, in this case, let's say it was 2 decimal places, it would be that. It's an area, so the units are square meters. And that would be the version. So your answer is either an exact version or it's a decimal, right? So let's do the one that we had a few minutes ago that's actually from the homework. And it looks something like this: 65 degrees, and the radius was 8. And the area is 1/2 r squared theta. And it's going to be 1/2 times 8 squared times, but not 65 degrees. Would you agree? Don't you have to convert it to radians? Now, since I'm doing a calculation here, couldn't I just put in what the calculation was and not worry about the answer, because I'll I'll sort that out later. Wouldn't the answer be 65 out of 180 pi? Would you agree? That's how you turn 65 degrees. Now, since I've got it in that format, with the exception of the pi button, couldn't I let the calculator do all the heavy lifting for me, right? So let's see what that would look like. It would be 1/2. I like putting brackets around things, even if I don't need them. So there's 1/2. Multiplied by 8 squared, multiplied by 65, divided by 180. And that's a decimal, which is fine. And then you do the math button, number 1, and it turns it into 104 ninths. Do you see how easy that was if I let the calculator do all the heavy lifting? So I don't need to, worry about cancelling and simplifying and, just making my life harder than it needs to be. Now, if you wanted the answer as a decimal, wouldn't I just basically write down 11.55 or whatever it would be? I kind of got that for free earlier on, right? Isn't that the decimal version of this guy? Oh, I forgot times pi. So I guess I would have to do something. So far, so good. So if I give you the radius and the angle in radians, you're good to go. If I give you the radius and the angle in degrees, you're good to go. So let's work the other way around. Let's suppose I give you, let's suppose I tell you that the area of the sector is 14, and that the angle theta is 0.7 radians. And I ask you then to find what the radius is, right? So that's our question. Well, I would start with the formula, 1/2 radius squared theta. I know that goes there, it's 14. I know that's 1/2. I know the radius is 0.7. Oops. I don't know the radius, but I do know theta is 0.7. Now, all I'm doing in this step here is I'm taking care of these two. And if I multiply them together, I get 0.35 r squared. It's just less work if you tidy things up. Now we need to go and solve for r, right? We're trying to solve what r is. And I have a rule called, as long as you do it to both sides, it's okay rule. So what should I do to both sides to get closer to finding the radius r?
Divide by 0.35.
Agreed. So I'm going to divide both sides by that. And I'm going to go 14 divided by 0.35. And the answer I'm getting here is 40. So far, so good? Right, what should I do to both sides to find the missing radius?
Take the square root.
Square root.
Agreed. Now, the particular question that this is a copy from, I believe, is question number 10, or at least a version of it. They don't mention to 4 decimal places. So that means they want an exact value. Would you agree that that is an exact value, right? It's not 3.9222 kind of thing. But can you simplify the square root of 40? I know it's a while since you did this, so I'll put it in a little bubble over here. But square roots can sometimes be simplified. What you need to do is think of 2 numbers multiplied together that give you 40. And one of those 2 numbers has to be a perfect square. It has to be numbers like 4 or 9 or 16. Can anybody see a combination that would generate 40?
4 and 10.
And then you separate them into 2 distinct square roots, and you end up with 2 root 10. So we call that the simplified answer. Oh God, where did you do that? Is that Math 94 or 99? Has anybody taken it and remember where they did that, or did you just do it in high school and forgotten where you learned it? But you should have seen that somewhere, right? Now, WebAssign might well take that as an answer, which I wish it wouldn't, because this really is the best version of an answer. I call that style points. Whenever you simplify something down right to its nicest form, I call that style, right? It's got some style, so I'm giving it some style points. I want it to be nice and stylish. And that would be the perfect way to do that. Has anybody done some of the questions where they've already answered the question and it took a square root of 40, or you needed to change it to the simplified version? Has anybody come across that? Because WebAssign is kind of hit and miss at what it will take and what it won't take. Sometimes it's very generous, and other times it's very, you've got to be right on it. Nobody experienced it, at least yet. Okay. So bear in mind that when you're doing a WebAssign question, if you type in that and it says you're wrong, don't automatically assume that the 40 is wrong. Couldn't it just be that you didn't simplify it? So have a quick check at that before you immediately, throw your arms in the air and say, I don't know how to do these questions anymore. So let's look at another version of that question. So this time we've got the area of a sector, and it's going to be 30. And we're going to tell you R is 5, and we're going to ask you to find the angle theta in degrees. Oh, to 2 decimal places. So I'll begin with our formula of choice, and area is 30, and it's 1/2 times 5 squared theta. So it's going to be half of 25, so what's that? 12.5 theta. Actually, you might not need 2 decimal places now. We'll see. What would I do to both sides to find theta? Don't overthink it. It's pretty straightforward. What should I do?
Divide by 12.5.
Okay. So I suspect this is going to be a nice answer, but that's just luck. 30 divided by 12.5. Yeah. Okay. So give the answer to 1 decimal place. And so that, take it back. Isn't that the answer in radians? It wasn't the question in degrees. So I want to get the angle in degrees. Not every question is going to do this, but aren't there some that ask you that? So how do I convert that into degrees? Well, don't we have a formula? for converting radians into degrees. There's a pi in the bottom. Anybody want to tell me the top two, guys?
2.4 times 180.
Angle in radians times 180. Now, in this case, it definitely is going to be a decimal, so I will have to round it off. So 2.4 times 180 divided by pi, and the answer I get is 137.51 degrees. And everybody is now happy. So I have done pretty much every version of that question you could get, right? Find this area of a sector, find the missing angle theta, or find the missing radius r. So I'm going to give you a question and give you, I don't know, 3 minutes to do it. And if you get it right, I'll feel good, because that means you've convinced me that you know what to do. So. And I've tried to make it as ugly as possible, because if you can do the ugly ones, the easy ones are a piece of cake. Right, you have got 3 minutes, go for it, no pressure. Coming up in the last 10 seconds. Okay, let's go for it. You can finish it off with me if you haven't. What would be the first step in this solution? What would I do first?
Find
I
theta.
converted degrees into radians.
Okay, and part of that would be also to put in area 10, to put in a half, to put in r squared. and convert it into, as you say, radians. So you could either do that on your own or just leave it as I have in this format, right? Would that seem, you know, you may have done it slightly differently, but that is essentially the first thing you did, right? Now, in my case, I would basically take care of all of this in one kind of major go. And since the answer's 2 decimal places, I don't even need to worry about making it look pretty. I just need to find out what I have times all of this is as some ugly decimal. So I'd go to my calculator and I do a half times 80 pi and divided by 180. And as a decimal, it comes out as roughly 0.698 r squared. Now you might say, but you only want the answer to 2 decimal places. Why did you write this to 3? It's always a good idea to be a little bit more accurate than not accurate enough. I'm going to round off to 2 when I'm finished. So again, there may have been slight differences here, but that's just a matter of rounding off. What should I do next?
Divide 10 by that.
Okay. And so, if I wanted to make my life easy, couldn't I just leave it like that for a minute? Because wouldn't the next step be just to take the square root of the thing? Now, by writing it this way, haven't I saved myself a little bit of work? I don't need to write down the ugly decimal, but I'm going to find the square root of it anyway. I just do it in one big messy calculation. Square root of 10 divided by 0.698. And I am looking at, to 2 decimal places, 3.79. Would you agree the 78? Oops, there we go. The 785 rounds off to 79. Now you might have got 3.78. You might have got, I guess, 3.80. Did you get an answer at least somewhere in that range? If you did, it's just rounding off that's caused it. It wasn't you did anything particularly wrong. Right, so do you feel comfortable about the area of the sectors questions? We good? So do you want me to do any more, or can I move on to some the puzzle questions? Move on?
Yeah.
Move on gets the job done. There are a couple of questions here. I think it's best if I show you them rather than write them down. No, I can write one of them down, okay. This one is a version of question 15. In this question, a car's wheel has a diameter of 20 inches. And they ask you, how far in miles, I'm guessing it will be a whole number, will the car travel if the wheel does 10,000 revolutions Oh, they only want to how far will it travel in miles if it does 10,000 revolutions, and they want the answer to be to 2 decimal places. Okay, well, when it's a puzzle question, sometimes you have to be a little bit more careful about, have they given me the numbers the way I really want them? And the first thing that strikes me is I don't want a diameter, don't I want a radius? And so I would turn that into 10 inches. Can you imagine that's the wheel they're talking about? And it goes round and round, 10,000 times. So what I'm going to do first is, if you think, what distance does it travel in 1 revolution? Great. Then that's the arc length, r times theta. And in 1 revolution, it's going to be 10 inches times 2 pi. You agree 1 revolution is 2 pi. Now, that's 1 revolution. It does 10,000 revolutions. Won't you just do 10,000 times that guy, which I'm now going to call 20 pi? Are you happy about where that calculation came from? One revolution is 20 pi, 10,000 revolutions is 10,000 times that. Now, I'm now going to turn that into a decimal, to 2 decimal places, and see what we get. 10, 1, 2,000 times 20 pi. And I get a ridiculous answer. It's huge because isn't the units inches right now? Have you ever done chemistry and they tell you units, 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 right? So we've got to be aware of this. Did they want to know how far it travelled in inches? Well, if it did, great, there's your answer. But it didn't. Didn't it want to do the answer in miles? So I'm going to take it slowly. I'm going to get the distance travelled in feet. Don't you just divide this number by 12, because there's 12 inches in a foot, and you get a slightly nicer answer, but not hugely nice. I'll call it 87 feet. Okay, Americans, because I'm used to metric, although I have done both. How many feet in a mile?
5,280 feet.
So if I take this guy and I divide it by 5,280, won't that be the answer in miles and we're finished? So I got the guy there, and 2,000, oops, try it again, 5,280. And the answer is to 2 decimal places. Hopefully I didn't hit any buttons wrong in that process. 9 and a bit miles, almost 10 miles. Okay, let me get my gripe over with because I'm easily distracted. So if someone bugs me, it's better if I phrase it. Why on earth is America and probably only the other 2 places in the world still on miles? Why do you use feet? You tell me any good reason why 12 inches are in a foot and 3 feet are in a yard and 1,760 yards are in a mile and 5,280 feet are in a mile, and that 16 ounces are in a pound, and so on and so forth. Why on earth any of that is sensible in today's modern age? Anybody here going to defend them? Defend America here? Come on. None of you, right? Would you all agree that life would be so much simpler if you went metric? Does anybody here know why you haven't? You've had years to do it. Why you haven't?
We're too stubborn.
So you figure out if you hang on to miles long enough, the rest of the world's going to catch on and say, that metric system isn't any good. I think we'll go and do miles. That makes so much more sense. Is that what they're aiming for?
Yeah, there you go. Now you're talking.
Okay. And the funny thing is, it isn't he's an American. Do you know that the feet and the pounds and all that came from Britain? You know that when you went independent, couldn't you have done what the French did? Because the French Revolution are the people who started the metric. And the French helped you, didn't they, during the War of Revolution? Couldn't they have said, hey, can't do a French accent, hey, want to try this metric system? And you lot said, nah, we're happy with feet, we're good. And then you got stubborn. Right, okay. That was a puzzle question. 16 is kind of like that, but much more difficult. The next one is a picture. So I'm going to go back and show you what this one looks like. And it's an irrigation question. So what they've got is a kind of irrigation system going on, and the pipe is 200 feet long. So basically from here to here. So haven't they told you the radius? See that? There's an obstacle in the way, some rocks. So the thing just goes from here and it irrigates to there. And the angle that it turns through is 240 degrees, right? And they want us to find the area that it's being irrigated. Would you agree that that is basically the area of a sector question? And it's not even the hard one, isn't it? The one where you plug and chug, right? The numbers are in the order and they're good to go. Isn't there only one thing you need to change here or be careful about? What's the one thing in that puzzle that needs to be kind of fixed before you start using the formula?
Theta.
Being in degrees.
Right. Are we getting comfortable now that when you see degrees, you just automatically know you're going to need radians? And that's pretty much the end of that question. Here's one where the angle's 135 and the radius is 22 and the little baby radius is 8. So this one's sneaky. Do you know when you do your window wipers go bump, 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 right? Unless you've got a really long blade, isn't there this annoying bit in the center that's still wet or got snow in it? And we're being asked to find the area of this piece. It's still the area of a sector, but actually isn't it the area of two sectors and you subtract one from the other? So what you would do in this question is you'd find the area of a sector where the radius is 22 and the angle in the center is 135, right? You'd get that. Wouldn't that be the big sector? And then you find the area of the little baby one. That would be the radius of 8. So that's from here to here, right? So that little guy is 8. And wouldn't you find the area of that sector again? And what would you do with the two answers once you got them?
Just
Subtract.
them.
Agree? So, anything else to watch out for in that question? Are the numbers good to go, or do you need to fix anything?
135 is in degrees.
Yeah, so yeah, maybe it's so obvious now you don't need to say it because you know you would do that without thinking. Right, I love this question. I really do. It's such a cool question. So I'm going to draw a version of this and we'll see if we can figure out how it's going to work. Take me a few minutes, I apologize for that, but it's worth it. There's that guy. Make this a different color, I think. That guy. This guy. And you got this guy. Take a few more moments. I'm just putting in the letters here. A, B, C, D, E. And what are the units? This is 100. 20. 60. 70, 50, 60. Okay. Just like puzzle questions. This one's very visual, which I like as well. So what you've got here is a cow that's attached to the end of 100 feet of rope. And the cow is going to graze. And as it grazes, it eats all this grass, right? And then if it goes a little bit further, it eats this piece of grass. And if it goes a little bit further, it eats this piece of grass. And if it goes back here, it eats this piece of grass. So when you want to find the entire square footage of grass that this cow eats, don't you need to find the area of all these different sectors? So far, so good. So for no particular reason, except I want to, I'm going to call this A. I'm going to call this one B. I'm going to call this big chunk here C, and this one down here D. So if we want to get the entire thing, don't we have to find the area of A, B, C, and D and add them together? Does that make sense? That's the approach to this question. Now, to get the area of a sector, don't we need to know the radius and the angle? Wait, the radius and the angle. So let's do C first. The radius is 100. And the angle theta is that angle there, right? You see it? In radians, what is the size of that angle? It's 90 degrees in degrees, but what is that in radians?
1/2 pi.
Okay. Now, things get a little bit sneaky. Let's do D. Its angle is also 90 degrees. So in fact, for every single one of these, the angle is going to be 90 degrees, 1/2 pi. But the radius is not 100. You got to imagine this rope reaching here, right? So it's now here. It's now here, right? Can you see that that's definitely not got a radius of 100? What is the radius of this little guy here? And by the way, it's not 60 either. There's
Is
your
it 30?
clue. Yeah, there's its clue. Do you see that when you reach here, you're going to have 100? But wasn't that 100 going to be made up of a 70 and another 30? And you see the 30 is the radius that you need. See how that was sneaky in its head? Does that make sense? 30. Okay, let's get B now. Same kind of argument. Imagine this thing gets to here, right? Which is 100. What does it make the radius? That distance is 100. What does it make the radius, which is here to here?
40.
40. Of course, isn't the angle still 90 degrees, which is 1/2 pi? And then you get to A, the last one, that little baby corner. I know the angle is 90 degrees, so that's good. What is the radius, which is this distance here?
That would be 20.
Oh, you got it. You want to explain to those who are saying, where the heck did he get 20 from? What was going on? How did you figure it out?
Well, if the radius is 40 and that A length is 20, then you know that the rest of the A radius is 20.
Does that make sense? Are you happy where that 20 came from? That was a pretty clear explanation for me. Right? And this is the point where I'm going to stop here. Don't you know everything that you need to find the area of A, B, C, and D? And from now on, isn't it just plugging into formula, rounding off, adding up, and you're done, right? So I'll leave the rest of that to you. Of course, when you get your homework question, I don't know if you've recognized this yet. Do you know WebAssign randomizes the numbers? So when you do this question 19, it won't be the same numbers that I've got. It'll be the same problem, but with maybe 120 where you used to be 100. So hopefully that you've bear in mind when you're doing that question to pay attention to your version of it. Nothing here, Carl. Oh no, that one is, I almost missed this one. I'm definitely going to do this one at least with the numbers they've got to the end. And the reason I'm doing that is that almost every time I forget to do it, I end up with 10 students sending me an email saying, how in the heck do you do this question, right? It's very innocuous. If you look at my version of question 22, I'll just write down what it says. It tells you that the wheel of a truck has a radius, has a diameter of 54 inches. That sounds familiar. We did one earlier with wheels. And it travels at 45 miles per hour. And it asks us to calculate what's called the angular speed. So I have to tell you about what that is. And they also want you to tell me how many revolutions of the wheel are done in a minute. Now, this is a heavy major duty question here, right? A lot going on. And we have got to figure out, I guess, right off the bat, which of these two formulas is going to be the one I'm going to deal with. Do you think I'm going to be dealing with areas of wheels, or do you think I'm going to be doing arc length? Which of those two, based on what you've read, makes most sense?
Be arc length.
I agree. So if the diameter is 54, can I just divide that by 2 and call it 27 inches and call it good? So far, so good. Now, if you travel 45 miles per hour, the units are miles, obviously hours. And I want to do, the angular speed, by the way, is in radians per minute. They ask, that's part of the question, make sure you're in. So we have to figure out how to keep track of the units. So my first job is to take 45 miles per hour and figure out what that is in terms of how many inches you would travel per minute. So far, so good? Okay. Let's see how I would approach this. 45 miles. First thing I'm going to do is convert that into inches. And where are you? 5,280 inches. Would you agree multiplying miles by that number is how many inches 45 miles is?
Isn't that feet?
Oh, that's feet, you're right. Wow. Shows you why I should keep well away from that. So isn't that 45 times 5,280 times 12 inches? Are we good with that now?
Yeah.
Now that is going to be some ridiculous number, but I do need to know what it is. So here goes. 45 times 5,280 times 12. Could you imagine how easier this question is going to be if it was kilometers? I mean, just think how simple this question would have become. But you want to be stubborn, then this is the consequence. It's going to be 285,1200. So that's basically 2 million and change inches. Let's check 45, 5280 times 12. Are we comfortable with that? Now that's how many miles per hour. So that's how many inches per hour. I'm now going to figure out what that is, not in inches per hour, but per minute. And so to do that, don't you take this number and divide it by 60. So divide by 60. And the answer I now get is 47,520 inches per minute. Are you still with me? All I've done here is figure out what 45 miles per hour looks like in inches per minute. So far, so good? Right, let's return to the question. The radius is 27 inches. So if I imagine this wheel turning once, then the arc length would be 27 inches times 2 pi. And that ends up being 27 times 2 pi. And I get 169.64 inches. We should be able to answer question B now. And question B is, how many revolutions per minute? If one revolution, it will travel this many inches. Then how many revolutions will it take to do that one, right? Well, the number of revolutions will be 47,520 inches divided by how far it travels in just one revolution. So would that make sense that you divide then, that's how many times the wheel would go round in that distance. So I've got 47,520, going to divide it by 169.64, and I get about 280. Do they have a mention of accuracy? Well, it's going to be 280.12 then. Let's just make it a whole number. Revolutions per minute. And now I'm going to do angular speed. Now the angular speed is basically how many radians does it turn in a minute? Well, I've got 280 revolutions. And for every one of those revolutions, doesn't the circle be 2 pi worth of turning? And so if you do 280 revolutions, you do 280 times that guy. And about 1759 radians per minute. Would you agree that is a bit of a stinker? Isn't that a thinking man's question? Thinking woman's question. Anything about that that you want me to talk a little bit more about? Like, how did you get from here to here?
So why did you multiply it by 2 pi again?
Oh, when you think of one revolution of a wheel, don't you turn 2 pi radians? So if you do 280 revolutions, won't you do 280 of 2 pi's? In other words, how many radians worth of angles do you turn?
Gotcha.
So
Okay,
it's a bit like going round a circle 280 times. Well, every circle's 2 pi radians, so 280 times that.
Gotcha. Okay.
Are we good with that one, guys? You know, you can watch this video later, you know, and pause over. Oh, is that what you did? Okay, I got it. I'm trying to find. Okay, this is the last puzzle one that I want to do, and then we can essentially call this section finished. I want to show you. It's a paddle wheel question. To measure the speed of a current, a scientist places a little paddle wheel. Have you ever seen them? They tend to be on a little stick, and you put them in the water and they turn, and it registers the movement and it gives you your speed. If you turn one of those vertical, don't you get the thing that tells you the wind speed as well? You've seen those kind of things maybe in documentary or whatever. It's quite a common way of measuring the speed of something moving. You basically have little paddles on it, and the water turns the paddle wheel, and so the speed at which it turns the paddle wheel isn't that the speed of the water. Or if you do it vertically and it spins, isn't the speed at which it spins, isn't that telling you the wind speed? So in this case here, let's get the key numbers. The radius is 0.5 meters. So I'm writing that down. Yay, metric. It rotates at 100, rotates at 100 revolutions per minute, RPMs. And we're being asked to find the speed in meters per second. Okay, that's the gist of what we need to know. Let's see if we can figure out the solution. So I got this little paddle wheel. Right, there's the river current. It's zooming around at 100 revs per minute. And we are being asked to find what that would be as a speed. And it's meters per second. So they've been a little bit sneaky here. Can you see that's revolutions per minute? But they want the speed in meters per second. So be careful with the units. So arc length, r theta. So I'm basically finding out what the turn, what one circumference would be. In this case, the radius is 0.5, and in one turn, it would be 2.5. And so in one revolution, it would go 0.5 times 2 pi, and it's about 3.142 meters. And so that's one revolution. Now, if you do 100 revolutions, then the distance would be 100 times 3.142, which is 314.2 meters.
So couldn't we just put pi in for it? Because 0.5 times 2 pi is
Oh,
pi.
You're right, I just noticed that. So in this case, it would just be 100 pi, which is actually much easier to deal with, wouldn't it? Yeah, I would have, if I'd thought of it. I'm going to turn it into a decimal at the end, but I think I agree with you, that's pretty. And so this is what 100 revolutions look like. So it covers that distance, right? Per minute. And you might have typed that in, and WebAssign would have said, you are wrong. Because don't they want the speed per second? So how do I use this number to find out what the meters per second is? This is how many meters it travels in a minute. How will I find
Multiply
it?
it by 60.
Is it multiply or divide?
Sorry, divide, you're right.
Okay. And if I take that horrible decimal and I divide it by 60, I will get 0. Okay, 0.05 roughly meters per second. If I left it as 100 pi, wouldn't it be 100 pi divided by 60? In which case that would become 5/3 pi. Something's not right here. And I can now fix it. That's not the calculation I just did. It's 314.2 divided by 60. There we go, that's much nicer looking. About 5.24 meters per second. Or if you want the exact value, 5/3 of a pi. The rest of the homework basically is watching videos and then choosing an answer based on the fact that if you watch the video, they'll tell you what the answer is. So I don't need to go over that. Anything about this last question? Because this is kind of natural stopping point. Are we good? Okay.